Okay, and so here's the tricky part of the law of sines, and I'm going to walk you through that. First things first is that I'm just going to use this triangle, and you don't have to mark this down. Use this triangle right here. And if you imagine yourself fishing, and this is your fishing pole, okay? And if you imagine that this right here is the water, okay? So what you can take a look at is that with your fishing line, you could have a line that is going to be here, and it could go ahead and swing back and forth like this, depending on if you've baited a fish or not, or just the way that maybe perhaps like your bobber's going back and forth in the water. So why is that an important visualization? And it's important because what we're looking at is that it's a situation where we're given an angle, and then we're given the side that's across from it, which is going to be this little a right here, and then we're given the length basically of the fishing pole, which is going to be right here. And when we solve for the angle B, okay, we don't know if it's going to be an obtuse angle or an acute angle, okay, or so it could come out as both. There could be two different triangles that we could make from that. We could also have a situation where, and I'm going to erase this out real quick, that your fishing line is too short and it will never hit the water, and therefore it could never make a triangle. So we would be given, again, this angle, this side, and this side, and come to find out that no such triangle can exist. So what we're basically looking at is that we're given information like this up top for something called an ambiguous case. Like, we don't know what's going to come of this unless we run it through the whole cycle of the law of sines and do things with it, which I'm going to teach you how to go ahead and knock out. So let's take a look at setting this thing up and how to go ahead and test for different things where you can have a possibility of one triangle, no triangles, or two different possible triangles. So here we go. Okay, so the first thing that I do is that I label out the sides, okay? And this triangle is just a template triangle, okay? It's not proportional or anything like that. Don't worry about the size of the sides. It's just a visualization for us to go ahead and see if this thing is going to work or not, okay? So what we want to do is that we want to set this up using the law of sines, okay? And we're trying to solve for this angle right here, okay? Because again, we would have, just from the previous video, we'd have this angle, opposite side, and then we would have, of course, this angle in its opposite side. So let's set that up and see where this takes us. Okay. So we have this all set up using the law of sines. And so what we're going to do is that we're going to attempt to solve for angle B. And so we're going to multiply each side by 62 to wipe that out. And then we're going to get this guy right here. Okay. And then we're going to take the inverse sine of both sides to solve for angle B and get approximately, we're going to go, this angle B is going to be 31.47 degrees, okay? Now, that is going to be our acute angle over here. And so when we have this situation where we have, again, I'm just highlighting them, angle, a side, and a side given, spells a bad word, that we have to test to make sure that two triangles can't exist, okay? Or I should say, to test if two triangles could exist, okay? So it kind of works both ways. And this is the way that we do it. So that's the acute angle, and I want to make sure that this angle right here, if that exists, B as an obtuse angle, I want to make sure that I include that as part of my potential answer. So the way that I test for this is that I'm going to take 180 degrees, okay, and I am going to subtract from that the 31.47 degrees, and I'm going to get 148.53. So here's the deal, is that this is how we determine if another triangle is possible. Is that if I add the given angle and if I add this angle together, and if it is greater than 180 degrees, because there's only 180 degrees in a triangle, okay, then we know that this triangle, the obtuse triangle, cannot exist. And so therefore, there is only going to go ahead and be one triangle, okay, that such that is going to go ahead and be like this guy right here, okay. So it's only going to have one solution, and for right now we just say that angle B is going to equal 31.47 degrees, and that's it. There's no other possible solution for angle B, okay? So let's take a look at what happens for a different scenario. Okay, so looking at this center piece right here and the triangle that's off to the right, I have everything set up. And what I want to do is I want to find the measure of angle B. So let's go ahead and see how, let's set up the law of sines and then knock it out from there. Okay, so the law of sines is all set up, and then multiplying through by 51, we're going to get this guy, and then we're going to have to take the inverse side of both sides to get angle B, which is going to give us, it's going to give us a, oh no, it looks like we're going to get is a domain error, okay? And since we have a domain error, this means is that given these values right here, no such triangle will exist, okay? So in this case, let's go ahead and recap what we've seen so far, is that here we have one possible triangle, okay? In this one, we have no possible triangle. And then we're going to take a look at our final example down here, and I'm going to have to erase some stuff out of here using this information, and I bet you that that is going to be the one where we're going to have two possible triangles. So let's go ahead and take a look. Okay, so labeling everything up, we have this set up here, okay? And so we're going to set up the law of sines and solve for angle B like we typically have done. So I'm just going to cut to the chase and solve for angle B. And I'm going to get 47.56 degrees, okay? So I know that that is going to go ahead, angle B right here is going to be 47.56 degrees, okay? Now, here's the deal, is that I have to check and make sure that this right here, the obtuse part, isn't possible or is possible just by doing, again, subtracting that from 180, just so we can check and make sure that another triangle doesn't exist. So far, just to be 100% certain we're all on the same page, we know that this triangle right here exists, where B is going to be an acute angle. What we are testing for is, does a triangle with B being an obtuse angle also exist? Okay, so, or could also exist. So let's do this, is that I'm going to take 180 degrees, okay, and the reason why I'm subtracting that 180 B from 180 degrees, because this angle right here, if that's true, then this would be B as well, okay, if it were to have that type of symmetry. And so therefore, this angle would have to be 180 minus B. And if that, again, if that's true, if I can add this angle and this angle up and still be below 180 degrees to give me enough angle measure for this angle right here, then I know I can make another triangle. So let's do that. So I'm going to back some of this stuff out, and let's do the 180 minus 47.56 degrees, which is going to give us 132.44 degrees. Okay? So if I take a look at this angle right here, which is going to be the 132.44 degrees, okay, is it possible to have another angle up here? And the answer is yes, because if I add these two up, I take this amount right here, okay, which is this guy, and I add the 40 degrees to that, I'm going to get 172.44 degrees. And so that means is that this angle right here can exist, okay? And I would find that by subtracting this amount from 180, and that would give me 7.56 degrees. So there are two possible triangles. There is possible triangle, the blue one, where B happens to go ahead and be an acute angle. So we would have B can equal 47.56 degrees. Or B could be an obtuse angle from this triangle right here, okay? And that will give me, B could also be 132.44 degrees, okay? So that is one of the tough things about the law of sines if you go ahead and you have the setup where, again, you have an angle and a side in a side, okay? And so, yeah, it's one of the things that, you know, even though the law of sines is great, you got to watch out for if you do have that pattern. It doesn't come up all the time, but when it does, you do have to check, okay? So, that said, let's go ahead and make our way on over to the law of cosines and see where that takes us.